All right, I'm going to try to very quickly get you caught up, those of you that weren't here or maybe are still confused about polar graphing. So here are some of our completed notes from class. Point A, these were from your homework. Point A is represented by the polar coordinate 2 pi over 3 because you can locate it by traveling a distance of 2 units away from the pole at an angle of pi over 3. So hopefully you can make it to point A by traveling around pi over 3 and out a distance of 2 units. You're also told you could do the same thing with 2 7 pi over 3. You can also get to A because pi over 3 and 7 pi over 3, hopefully we know, means they're coterminal angles. They land at the same spot. So we could go around the circle and another pi over 3 and land at A. We in class gave 2 more options for landing at A. 2 negative 5 pi over 3. That negative 5 pi over 3, we're not going to start there, is coterminal. Negative 5 pi over 3 is coterminal to pi over 3. We go out a distance of 2 units. We'll save this guy for a minute because that negative 2 could throw us off before we learn about it. We practice going to negative 7 pi over 6 to land at point B. So if we travel negative 7 pi over 6, you got to know your circle. Negative direction, a little bit past pi over 6. Past pi takes us to 5 pi over 6, out a distance of 2 units. We're at B. Okay, so basics of polar graphing there. We then looked at a little bit tougher spot, but a point distance from the pole will always be positive. Distance is always positive. However, that doesn't mean you can't have a negative R value, but it's not as straightforward. The point C can be represented by both coordinates here. So let's go verify these for ourselves. The first one says go around 5 pi over 4 and out a distance of 3. And there we are, we're at C. The second one says go around a pi over 4, and then we have a negative 3. Well, pi over 4 is definitely not out at 3, or C is not in that direction. But if we go 3 in the exact opposite direction, so pointing back the other way, kind of like wind blowing out of that direction, we land at C. So a negative radial value means go the opposite direction, the exact opposite direction. We practice with point D, 4, 0, so point D is over here. That means go around an angle of 0, which is your anchor point, and go out a distance of 4. There's D. We also decided you could go around a distance of pi, and instead of going 4 towards pi, we're going to go 4 in the exact opposite direction and land at D. So here you should verify, pause this, verify for yourself, check some of these answers to make sure that you understand them. Once you've checked them, so you know these are called polar coordinates. They're in the form r theta, not to be confused with xy. Xy are your rectangular coordinates because you move on a grid that's made of rectangles, really squares most of the time. R and theta are called polar coordinates because you revolve everything around a pole in the form of circles, like a North Pole. Imagine you're looking down at the North Pole from above it. Okay? Very quickly, pause, check this graph, fix yours. Number 8, number 9, number 10, number 11, the best of all, number 12. And then we're going to move on to the new notes. We're going to look at functions. R is a function of theta. We are used to y is a function of x. Now we're going to have a function of theta, and that function will equal r. Sometimes we see y equals f of x. Now we have r equals f of theta. Because of that, r must depend on theta. R depends on theta. Theta is the independent variable. So even though we write x, y coordinates and we write r theta polar coordinates, they don't correspond. X is our independent, but r is not our independent variable. So don't get in the habit of associating x with r, even though it comes first. If you turn, or I guess we're going down, we can plot these on a rectangular graph. This is your theta axis because it's independent. R depends on theta. R equals 2. That means no matter what theta is, no matter what, the R value is 2. kind of like in algebra, y equals 2, you get a horizontal line. But on the polar graph, you get a circle whose radius is always 2. No matter what theta is, you're at an r value of 2. Compare that with theta is negative pi over 6. You've got the theta axis and the r axis. This says no matter what, theta must be negative pi over 6. So wherever you want to put negative pi over 6, theta is always that. It's kind of like x equals negative 2 or x equals negative pi over 6. It's a vertical line. On the polar graph, r can be anything, and theta is always negative pi over 6. So he said, okay, theta is always negative pi over 6, which we could have also called 11 pi over 6. But we decided, we asked, do we go both ways? Should this line extend in the other direction? Well, we have negative r values, which means you also go in the exact opposite direction. So on the polar graph, this is a line that extends both ways. We then turned our page. We did something, you'll get to this part in a minute. We did something that we don't normally do. We filled in this table. We plotted points one at a time in this table. Okay, so we plugged in 0 into theta. Sine of 0, 0 times 2 is 0. Sine of pi over 6 is 1/2 times 2 is 1. Sine of pi over 4 is root 2 over 2 times 2 is root 2, and we approximated that to be 1.4. Sine of pi over 3 is root 3 over 2 times 2 is root 3. We got that to be 1.7, and then we finished this table. Using those numbers, you should go plot your sine graph on the rectangular coordinate system. Notice, I want you to use one color when you're positive and one color when you're negative. From there, what we did is we moved to the polar plane and we use a positive color and the negative color. So when r is 0, theta is 0, so that means we're at the pole. Pi over 6, 1 says go around a distance of pi over 6, out a distance of 1. Don't connect your dots yet. Pi over 4, go out 1.4. So we're going to go around to angle pi over 4, but out a distance of about 1.4. Go around pi over 3, out a distance of 1.7. Go around the pi over 2, out a distance of 2. As you know, there are infinitely many angles between 0 and pi over 2. We've just plotted 5 points. So if we plotted them all, we would see this nice and curvy, not straight lines. So when you connect these, we connect in order, nice and curved, and get here. You continue around. You should plot these nicely for yourself. But there they are quickly for you. That's really should be curved a little bit more. Then we switch colors because once we get to pi, we have negatives. But when we go towards 7 pi over 6, go around 7 pi over 6, but r is negative 1, which means we go the opposite direction and land right back where we started. We go to 5 pi over 4, but r is negative 1.4, which means we go 1.4 in the opposite direction. Go slowly through these. You'll find yourself overlapping all your points. Connect them in the order they get plotted, and you get a circle with a radius of 1. It looks very nice. Everything else, you should be able to try to follow along in the notes that are posted on Google Classroom. I'll be in Tuesday for help if you need it. I hope this was helpful for those of you that are confused or who missed this lesson this week.